Hello everyone. I'm very glad to here to give a presentation on the topics holism versus reductionism, system development life cycle, and data backup and disaster recovery planning. So these three papers which we done in this class from the first 3 weeks. So let's see the executive summary of these three papers. The first one is holism versus reductionism. So still, we know that we all know the basic definition of holism versus reductionism. That is, holism is considering the whole thing as a part, and reductionism is dividing the part into smaller units. So let's take for an example. I want to give an example for this. To give instead of giving a traditional definition. So let's take if I go to a car showroom. If I look at the car, the first thing I look at the car is how it's looking. So on the basis of looks, I'll purchase the car. As per my context, I call it as an holism because I'm just giving the whole context for the priority rather than individual part. So as in the same way, if you consider as a reductionism, I I buy a car by checking the all, like I drive the car and I check the sound and the speeding and the gear and everything, like acceleration, everything I'll check it. And and the com- and coming to, if there is if I done any repairs to that for an individual part of the car. So as an individual part for everything, there's an individual part, we call it as reductionism. So from the many people discuss like they feel like holism is better in some context and reductionism better in some context. Yes, it's true, but it's difficult to choose one exactly to overcome other. It has an individual, like holism we use in specific purpose, and reductionism we use in a different context. So both are independent, both are different in their context. Coming to, so we all know that holism is considering the whole part to strive overview of the relevant aspects, and advantage of holism is, as I said, we can get a better idea or better overview of the system, because as we look on entire system, so we can get a better idea. And coming to reductionism, we can get better to explain, better to understand on the complex systems. So we break the complex system into parts, so it's easy to understand. So advantage of reductionism is that, so it's easy to understand the complex system by dividing it. So when we compare the holism and reductionism, the holism is used for validating a system as a whole, and the reductionism is used on each process of the focus on each process of the system. So that's it. So how we use is dependent on the product, depends on the decision of the company. So the next one is coming to system development life cycle. So we all know that system development life cycle, it gives the efficient system or efficient product to the customers. So in the system development life cycle, there is the models like SDLC to develop a software development life cycle, and there's some models like 7-step SDLC or 4-step SDLC. So the coming to software system development life cycle as a whole, if you consider, it's about whether it is hardware or software. So especially for software, it's called as a software development life cycle, and there is some models involved in that. In this, let's take some. If you consider any organization like for IBM or any Microsoft, if they going to do any project, so they work according, if they use like SDLC models, in that some various models like waterfall, these models they approach for those dependent on the type of project and kind of project. So every SDLC step, like if you consider 7-step SDLC, we have phases like planning, analysis, design, development, testing, implementation, and maintenance. So coming to planning, it's a crucial step. If we do mistake here, the entire system will go wrong. And planning is about what scope of the project. It's mainly depend on scope of the project, what the project we are going to do. And coming to analysis, we have to analyze what the requirements we have and what are the sources and what are the available sources we have, and how to proceed with those resources. Coming to design, with all these resources, we go further to design the design the overall plan of the project. uh, Here the next step is the development. In this, the developers will involve, and they made some code to develop. If we, especially in the software, they will develop the code and they will send to it for the next process, that is testing. In the testing team, like they do some system testing and unit testing, those kind of testings to get a better work performance. So after that they'll go for implementation. Plus implementation means it's directly giving, after the testing, after checking the efficiency of the product, they will deliver to implement to use of the customers. So after implementation, we have to do maintenance about to check the performance of the system, how it's working, and if there is any issues, we have to take care of those. And coming to four-step SDLC, it's planning, analysis, design, and implementation. So here the testing and these two will be merged as implementation. So it will act as an implementation maintenance. So this is the four-step SDLC model. The best example of four-step SDLC model is spiral model. So if you consider a spiral model, uh, for example, as I discussed in the class, spiral model is very fit for to identify risk in the product. It's the best suit for gas station, as I discussed in the class, because the spiral model, in each iterative step we worry about the secure risk analysis. So the best example for first step SDLC is spiral model. uh, and comparison between 7-step and 4-step is difference in implementation step. And coming to 4-step SDLC, product based companies will prefer 4-step SDLC, and software service providers prefer 7-step SDLC. And coming to the next, this one, executive summary of the paper is data backup and disaster recovery planning. So data backup, as we know that data is a very important asset for any organization. As a individual also, data is very important. Our data is very important, so we'll back up our systems, our data to the systems. So it's very essential to take backup. We have some sad incidents have experienced in the past, like World Trade Center. We know that how disaster has happened and how much data we lost, how much it's affects the organization as in the economically, and as well as in the infrastructure, everything. So to avoid these type of disasters, planning, and to continue to make organizations to continue the business, we have to take the data backup, and we have to provide when they are needed. So coming to data backup, we have some types of backups, like full backup, differential backup, and incremental backups. Full backup is about taking all the data into a single all the data into full backup. Like we consider it takes time to take a full backup. And coming to incremental backup, we do all the modifications to the data. So only the modified data will take a backup. And coming to differential backup, the modified data for 2 or 3 days backup, 2 or 3 days data will be backed up in this step. So like that we do the data as a backup. So coming to disaster recovery planning, so after we back up the data, we have to record the data to the organization when there is a disaster occurs. So here we consider as the two aspects, like recovery time objective and recovery point objective. The time objective is at what time, at the exact time when they needed, we are providing the data, and the recovery point objective, at which extent we are giving the data to them, and how accurate it is. So there is involvement of service level agreements, that is between client and the storage provider. So that's it. Thank you.